We have very mature chemical industry that is based on fossil fuels. But there is a very short amount of history to really understand how we deal with CO2, how we can make use of CO2, how we can capturing this CO2 to avoid emitting them into the atmosphere.
You know, these problems that we talk about, the real big problems, the climate issues, the CO2 issue, health issues. It's not just a chemical engineering thing or a chemistry thing, it's about solving the problem. And what Haotian has done over the last several years is to say, hey, there's a certain path forward where we can combine electrons and molecules to do something about CO2, something about water pollution.
I really love carbon dioxide chemistry. I want to pursue carbon dioxide for capturing it, for converting it into useful products and so on. That's what I'm passionate about.
He's one of a very, very small number of faculty who are really on a very intense trajectory in terms of their accomplishments. He's publishing top-notch papers in the top journals in the field, Nature and Science.
He's extremely creative. He's always pushing the boundaries. Every time I turn around, he's sort of pursuing some new areas that we know are absolutely critical in the broad domain of energy.
And he has this ability where he can identify the research questions that will resonate with the field. He's really incredible at defining the gaps in research. And then once we go in that direction, you will see a lot of high-impact research coming out of it.
Haotian is an interesting case. He's in between. He is a chemist, but he's really in a chemical engineering department. He does fundamental science, but then translates it.
You never know what type of fundamental research could grow into a huge impact for groundbreaking applications. The fundamental understanding may sometimes translate to real impacts in practice, may sometimes not. But you will always find out that a lot of your fundamental understandings, and you publish it, it will benefit to many researchers all over the world. That's how our research community can evolve and benefit from each other's findings.
And this is where Haotian's research comes in. He's a top-notch chemist. What he said was, hey, look, I know how to take that CO2, convert it into something like acetic acid or formic acid. And those are starting materials for a whole bunch of other chemical technologies.
The beautiful part about our technology and our research is that we use a lot of existing infrastructure. So that can be something that that's inspired from fuel cell technologies or water splitting or water electrolyzers.
So water electrolysis is a technology that utilizes electricity and water to produce hydrogen and oxygen.
In this case, some of my research presentation titles is water plus air plus electricity equals hydrogen peroxide. You just need these three elements to manufacture hydrogen peroxide on site.
So these technologies have been around for years and years, and their infrastructure already has been developed in a way that allows for a fast deployment from lab scale into commercialization.
That's our dream. If there is a device from our lab can walk out of the lab and really make real impact in the world, that's the most rewarding part of our research outcomes.
And that's what's unique about his work, is that it's both theoretically and fundamentally sound and just outstanding, but he's always thinking about the end goal. How will this eventually impact people's lives? And he's actually had things that are transformative from that perspective.
Where they can use the fundamental science to trigger something which is applied. And so the environment here is very fertile for people like Haotian to go and innovate. He's one of our superstars, no question, which is why he won the Hackerman Award.
I was really, really surprised to be an awardee of the Norman Hackerman Award, because I know this is one of the most prestigious awards for early career researchers. It means a lot to me, to my family, to my research group, and also to our CO2 electrolysis, CO2 catalyst community.
Haotian's an excellent recipient of this award for the main reason is that he's doing some of the most cutting-edge research in chemistry right now in the world. Some of the things he's doing with lithium, ions, and wastewater Can you do something with electrons to help recover some of these dissolved critical minerals?
Yeah, for me, what's most exciting is that there's kind of been a recent, I guess, mood shift in the field of electrocatalysis. The mood has shifted to being more practical in a shorter amount of time. And that means we have to scale up and we need to tackle problems as quickly as we can.
We can borrow a lot of ideas in batteries, in photovoltaics, in many other applications into electrocatalysis, even biology into electrocatalysis. That's how fundamental breakthroughs could happen, because you involve the new tools, new ideas, new concepts into the field.
This is the start, and it's amazing to see him come so far.
I just can't wait to see what the next 5 to 10 years holds for his work. I'm just so excited that we have him at Rice. I'm so excited to have him as a colleague. I know he's going to continue to do great work as well as mentoring the people behind him.
I'm very, very excited about the future, not only in the technology itself, but also the talents that we keep producing, training our next generation of researchers and scientists, and also leaders in the renewable energy areas.